So just to recap where we are right now, we've added a PLC to the project. We've added I/O modules to the PLC and the rack. And then we've looked at configuring I/O modules. And really the last piece of that puzzle is to configure the CPU. Now you might feel like we've already done that because we went through the wizard at the beginning of adding the CPU to the project, but that's only the security settings. There's still quite a lot more that we need to have a look at. So there's two ways of doing this. If we come into device configuration, which loads our devices and networks window on the device view, and have a look down here at the properties, which is the way that we did the modules or the I/O modules, you can do it all in here, but I don't like this view for doing this because it's too compact. You've got to drag windows around and things like that. So I'll show you a different way, which is to right click on the PLC here and go to properties. And this will load it in a middle window, which might feel like it's smaller, but you can drag it larger basically, which gives you much more view and scope as to what's in here. It's much nicer than working with the properties section at the bottom of the window, especially if you click something else and you lose it or it collapses and all that sort of stuff. So it's opened on the protection and security because the protection and security is the last thing that we actually did with this CPU because it's the first thing that it asks you to sort out. So if you wanted to run that wizard again, you can click it here and that'll open the security wizard again. And then all of the things that you actually set up are all stored in this protection and security section here. But we're not going to go through this right now, and we've sort of already been through it with the wizard anyway. What we're going to do is come right up to the start and we will collapse everything and we will just work our way through this list. So just like the modules, we have a general section for project information. We have catalog information for our CPU. We have the identification and maintenance, and then we have an additional thing called checksums. So what a checksum is, and I'm not going to dwell too much on this, but you end up with a special GUID or GUID, which is a unique number based on parameters and things that the CPU is checking for. So you have one for text lists, which are all your language options and strings that you have in your PLC. And then you also have one for software. Now, because we haven't compiled, like we don't have any software in the CPU, we've never run a compiler, we don't have anything in here. But this is what the CPU uses to or what the project uses to check the CPU when going online. So it will take this number, although it would be software, it would take this number and check the online or the hardware's checksum, and if they're different, it would then show you why they're different. But it's the quick way of saying I know something's different between these CPUs because they don't have the same checksum. So there's nothing you can do here. It's just for you to have a look at. It's a very easy way of having two different versions of a project, or I have a version and a colleague has a version, and we want to see if they're the same. Have you got the same checksum, yes or no? So in here is our Profinet interface. Now you might not have this if your CPU doesn't have Profinet, but pretty much every CPU has Profinet, and you might have additional sort of network configurations in here if you have something like Profibus as well. So this list is only dependent on what your hardware is capable of doing, or only shows things that your hardware is capable of doing. From here, you can name your Profinet interface even, and say who the author was and all that sort of stuff. We'll come on to this for interface network with. This is where you can create a subnet to hang other devices from. Importantly, let's actually go and have a look at this in the more compact view. So Ethernet address setup. This is where you set your IP address. Every PLC that's brand new comes with 192.168.0.1. So if you ever want to configure an actual piece of hardware, that is what the IP address will be. You can set things like DHCP server access, so it gets its own IP address, or even tell the PLC that it's set directly at the device. So you're not able to set it through the project anymore. It's set directly on the device, which is useful if you're constantly loading different software applications in and things like that you don't want the PLC to change its IP address. And some Profinet setup down here for generating names or getting the name to be set by a different device. Operating mode, if it's operating as an I/O device, so a slave to another device, that's set up here. You'll notice that when I clicked I/O device, some additional options appeared for things like iDevice communication and real-time settings. I'm not going to go through these now. iDevice is quite an interesting one to look at, and there is a lesson in the appendix for this if you want to go and check that out. Typically speaking, it's still uncommon to have a CPU acting as an I/O device, but the iDevice is worth checking out if that's something that you do. If I come into advanced options, remembering that we're still within Profinet, this is your configuration for how you want your interface to work. So call the user program if communication error occurs, so cause a diagnostic interrupt, support device replacement without exchangeable medium, permit overwriting if device names, overwriting of device names of all assigned I/O devices, which allows other controllers to change names. And limit data feed to in-feed of network. Typically speaking, again, very common default setup here, like you don't need to change anything unless you know what you're doing. Security settings, media redundancy. This one doesn't have anything like that anyway because we're not in a ring. Real-time settings, again, only really changing this stuff if you know what you're doing. We're in advanced options after all. And some port setup configuration. And this could be important to some people because some of this is to do with setting topology in terms of what's plugged into what the transmission rate is for different sort of cables and lengths and things like that. Set to automatic, and in nearly all cases, you can just leave it as that. Web server access allows whether or not the server for this network or this network interface is enabled. And that allows you to have a look at things like configuration and in some cases even access PLC software information such as CPU tags. So here we have our startup options, and we're now out of the Profinet interface. We're back in the CPU, so this is to do with our actual controller. Startup after power on, default is warm restart. So if you were running before, it will attempt to go back into running, but if you were stopped, it would stay stopped. So you're never going to have it that if you've manually stopped the PLC by clicking stop or on the actual hardware itself going to stop, and then the power gets turned off and back on, the CPU will remain in stop. You can have no restart, which is it's always in stop mode no matter what. And you can have warm restart run, which means it will always go into run. That can be a little bit dangerous depending on the application, because if you've put it into stop and then you have a power fault or the power goes off and then it comes back on and your CPU restarts, it will go into run, which might not be what you want it to do at that time. So I recommend leaving it in this mode. Comparison presets to actual configuration. So remember in the module lesson when we said what do we want modules to do if we had mismatched information? It's the same thing here. Start CPU even if mismatch, start up CPU only if compatible. Default is to start up the CPU even if mismatch, which allows the CPU to actually start the sort of program management side. And then you have a configuration time, like a time window to allow other parts of the system to come online. Here we have our cycle. This is actually more important than people realize. I'm not going to go into it too much, but the way communication works with CPUs in the S7 system is they use some of the cycle time to make communication. If you've got a particularly heavy PLC in terms of what it's doing, and it's always against its maximum cycle time, so say 148 milliseconds out of the 150 that you've given it, it will never have time to do communication because communication is one of the lower priorities. So I like to give a minimum cycle time where applicable, and that would be something like 75 milliseconds, and that would allow my program to execute. And just say that takes 50 milliseconds, it would mean that I always have 15 milliseconds for comms and for various other things that the CPU has to do outside of my scan cycle. I have run into issues with that before, not by setting a minimum cycle, but for not having one. So it is always something that I'm an advocate of. You should obviously set your minimum cycle time to something that is safe for your application. Communication load, this is what I've just spoken about. So cycle load due to communication. What is the maximum cycle load, the maximum amount of your range for your cycle time up to your maximum that you're going to allow for comms? So remember, this is not, it's going to put 20% load on, it's what's the maximum load it's allowed to induce. So it still might only put 1% on if that's all the room that you've got. But if you start having communication issues where you're not getting information on SCADA or to another HMI or to another PLC, it can be something between this cycle and communication load. System and clock memory. Personally, these should be on by default. I don't know why Siemens turned these off. So turning this on allows us to have some memory flags that hold some pretty useful information or flags for our project. So M1 would have first scan, a bit that's only true for first scan. M1.1 says that something's been updated in the diagnostics. This one here, M12, is always true, and M13 is always false. Very useful flags because although you can type constants in, just true or false, you cannot cross-reference a constant. So finding out where you've put something to always be true or always be false is actually really difficult if you don't use this tag. And this should be enabled as well, really, which is enable the use of the clock bytes. This gives us some timings that are based from the CPU, so nothing to do with our software. It's probably the most accurate way that you could actually get a particular clock cycle. Like having a timer, like a Tom timer that goes true every 1 second for one scan is great, but if your millisecond scan time is something that doesn't line up exactly to 1 second, then you're always going to have that little bit of overhang, and that accumulates over time, whereas these don't because they're asynchronously updated. Obviously, you still have the issue with your scan time, so PLCs are not perfect timekeepers, but I would still use this for anything that is really, really time sensitive and critical, or use an interruptible cycle OB, which we'll come on to later. These are some memory card options, or one, which is the aging of the memory card. Throws a diagnostics warning. Basically, when you get to a particular threshold for the aging of the card. And it's just to remind you that flash memory that are on the SD cards only have a particular amount of read and writes before they lose their integrity, basically. But to this day, I've never seen that actually happen. System diagnostics, some information and parameters around what to do with your system diagnostics. So this is a useful one: suppress the alarms for deactivating I/O devices, and also report network faults as maintenance instead of a fault. Sometimes having that red flashing light on the hardware can cause operators to raise, there's an issue with this CPU, or lose trust in it as a process, when actually there's nothing really wrong. It's because maintenance are taking cables out or rerouting something or working on some part of the infrastructure, network related and things like that. This can turn that stuff off. PLC alarms for central alarm management. We'll come on to that later on in the course. And then you have your web server, which I'm not going to go through because it's not really used, or I certainly have never seen a great use for it. But the web server's here if you do want to set anything up. You have your display, which is actually the display on the front of the hardware, not to be confused with having a HMI in your system or anything like that. This is the little screen on the front of the CPU. You can set up some backlight stuff, energy saving mode, the language, automatic update for diagnostics and other things that screen can show. You can also add some passwords, display protection and things like that, or turn off write access so you can't change anything. I don't know if anybody's ever actually gone through the screen and had a look at what you can do on there, but there are quite a lot of options for changing things like IP addresses, accepting and clearing diagnostics messages, turning off write access stops that stuff from being able to be done. You can set up watch tables for critical processes, so you can actually go to the front of the CPU and see some watch tables and read tags out and things like that. User-defined logo, so instead of just the splash logo that comes up in energy saving or when the screen's idle, you can actually set your own logo and basically upload or download into the controller something to be displayed there. If you're like a OEM that is doing work that offers support contracts and things like that, it's quite a useful place to put a phone number or an email address to say if you need support, contact us here. A lot of the time people go straight to the panel and start looking at the PLC or looking at the controls. It's quite useful to sort of put that stuff on there. You have multilingual support here. Worth noting that if you don't have the language packs installed, then you can't actually set anything here. You'll notice that English United States is what's to be used for all of my languages because I don't have any other language packs installed. That is something that is common theme throughout TIA Portal, that if the language pack is not installed, it'll either not show the option or it'll be defaulted to English because that is the default language. Time of day. This gives you the option here to set the time in the CPU to be synchronized with an NTP server. You must have the NTP server reachable, which means that you need to set up a gateway or your NTP server needs to be on the same network. For example, you can set an NTP server directly on a device, in the PLC program or in the display, set it via the project, set it remotely via DHCP, and basically warnings about security and things like that. But most people will set up the time of day via the diagnostics menu, which we come on to later in the course. Daylight saving time, useful in some applications, not very useful in other applications, or causes issues depending on what you're doing with time of day. If you're not familiar with what daylight saving time is, it's where you move the clock forwards or backwards by an hour depending on where we are seasonally in the year. I don't think every country does it, but we certainly do it here in the UK. And yes, it can cause problems, especially with archiving information and things like that, and especially when the clock is going backwards, so you're writing back over time that you already had. That information tends to be lost, which is frustrating. And yeah, you can set up when your start of daylight saving time is and things like that. Protection and security, we've not run through everything, but we've run through enough with the Start Security Wizard. I'm going to leave that out for here. OPC UA, we have a whole section on OPC UA in the appendix, so I'm not going to go over that now. If you're interested in how you can do OPC UA as a server or as a client, then I recommend having a look at the appendix because that's where you'll find the best information on that for this course. System power supply. This is where it's actually quite useful, where you can see how much power consumption your system is going to use and therefore spec your power supply for your system appropriately. You can also say whether or not the CPU needs its own connection to supply voltage or no connection to supply voltage, in which case you would need to power these a different way. We have advanced configuration here, which is a lot to do with IP and sort of network setup, IP forwarding, access to PLC via communications. I'm not going to go through this stuff because we're far too early in sort of courses for this type of configuration. Here we have our connection resources, and in here it just gives us some information around our maximum types of connections. So 4 simultaneous PG connections, which are your programming environments, 4 HMI connections. Remember that this is the CPU. I'm not quite sure why it says 0S7 communications, because you can definitely connect this CPU to another CPU and use S7. But yeah, it basically just gives you a little table of our resources, mainly around communication for the CPU. And then here is overview of addresses, which is a very useful table for for pre and post commissioning, being able to say this is what we set everything up to, this is where our card addresses are, how long they are, what the offsets are, what the module is that's using them, what slot they appear in which rack, and all that sort of stuff. Very useful bit of information there just to make sure systems are set up the correct way. Or if you do the CPU before the electrical wiring, to be able to pass off to somebody for wiring and say this is where everything is in terms of slots, it's how the CPU is configured. And then finally, runtime licenses. Nothing in Siemens is just free. So OPC requires a license, and you set your license here. And also ProDiag, which we have seen, but is actually under PLC alarms, which is central alarm management. If you are using central alarm management or ProDiag, and the system detects that you're using more than 25 supervisions, so supervisions are monitoring of a tag or an event, then you are required to purchase a license. And yeah, you need to come in here and tell TIA Portal that you have a license. You don't need to prove it, but I guess you could be asked to prove it. I don't really know what the conditions around that are, but you will get an error during compiling if you haven't set a license in here. And that is just a case of saying, I have a license and I have a license, and those compile issues will go away. But I guess you could be challenged by some means as to proving that you have that license. Once you're done, click OK, and your CPU is configured. And that's pretty much it for setting up the CPU fully with all of the configuration options that are available.